Hello.
How's it going?
It's going okay. How are you doing?
I'm doing good. I survived that tornado last night, so I guess I'm doing pretty good.
Was there
Yes,
actually a
but
tornado?
there was a tornado watch.
Yeah, I have no idea.
I
We
don't
just
know
had
if there
one.
was or not. It kept me up most of the night, though. I know that.
Yeah. My dog got scared. She had to crawl in the bed with me.
Oh,
She
no.
did not like it. She's a big German Shepherd, so
And my 3 little dogs, who have every right to be scared, slept right through it.
that's funny.
Storms have never bothered them for some reason, and I'm thankful. Storms, fireworks, I have no problems.
Well, that's pretty good.
I know, for 3 dogs. I mean, because it is common for dogs to freak out about stuff like that.
Yeah, I know. I guess they just feel safe inside.
I don't know, but Bartok will occasionally bark at them, but it's more like, I'll show you who's boss. So, all 6 pounds.
Is that the wiener dog?
It's a Chihuahua.
Oh, okay. My parents have a wiener dog, and she's just all about showing you who's boss.
No, Eliza's pretty docile for a dachshund. She loves to play, she loves to eat, and she loves to sleep. And other than that, you can do anything you want to her, and she's not going to care. I mean,
That's funny.
yeah, she doesn't even hardly. The only time she barks is if I'm not getting her meal fast enough. Or if she's playing and I'm withholding her toy for some reason. So that's the only time. Other than that, she never barks.
Ours, Hope, she'll like, if someone comes inside and you're in there, you're pretty much losing your hearing. She has the most high-pitched bark.
Oh, yeah, that's annoying.
So,
yeah.
What's the status on the tests? I'm assuming you're still grading them.
Oh, that's so funny, Chris. So actually I haven't even started.
Oh, okay.
So I had I gave all 5 tests last week. All 5 of my classes I gave tests. And you guys were the 5th test. So you were last in line.
Okay.
And I got all the first 4 I got graded by late Saturday night. And by that point I had put in over 60 hours, and I was like, I'm taking Easter Sunday off. And so I did not do any school at all on Easter Sunday. So I'm hoping to start them tonight. So sorry, I know that's not what you wanted to hear, but
no, it's fine. I just wanted to know the status on it.
Yeah, that's understandable. I do feel bad that I haven't even started it, but I'm finding that I can only do so much, that I can't do everything. So, all right, I'm gonna real quick, while we're maybe waiting on just a couple more people, get attendance here. So if you want me to count you present, I'm gonna need to see you. So unless there's an issue, for some reason, and you've got a really good reason that you don't want me to see you, but I think I told you this last week. I can't remember if I told you guys this or not. I am finding that it is incredibly difficult to teach to just a bunch of little black boxes. I need to see human beings. So, So yeah, if you've got your camera hidden, go ahead and unhide it. That would be great. You'll make me happy.
Unfortunately, I do not have access to a webcam.
Okay. All right. Then you're going to have to participate a lot then, Chris, for me to believe that you're still there.
That's fine. I have no problem with that.
Yeah, I figured.
I don't have webcam, as you say.
So same thing. Yep. Participate. There you are, Richard.
I will be right back, though. I'm going to get some water.
Okay.
Ms. Roberts?
Yes.
I got a couple questions from the Learn.
Okay.
When it's like, because let me try to find the problem. It was just LN. I was wondering, because it was like LN to like an exponent.
Yeah.
Would it always be E for the variable?
So can I, Jarquez, would you mind terribly if I hold off your question until the end of the lesson?
Yes, ma'am.
You would mind?
Oh, I wouldn't mind.
I'm playing devil's advocate there. And the only reason I say that is I might actually end up answering your question through the lesson. And if I do, great. And then if I don't, though, I want you to make sure that you ask it again, okay?
Yes, ma'am.
So I'm only gonna ignore it temporarily, not permanently. Can you guys also make sure that you've got your formula sheets? Because we're gonna be using those a good bit for chapter 5. So there's a lot of the derivatives and integrals that I have memorized up to chapter 5, but then with chapter 5, for whatever reason, I think it's because I don't use them as frequently. I just don't have these memorized, nor do I expect you to memorize them. But they're a lot more unfamiliar. So just make sure that you've got mostly just the derivative and integral formula sheet. The other ones, I don't know that we're going to use those any. But the derivative and integral sheet we'll definitely use today, as well as for the rest of chapter 5. So just make sure that you've got that handy. And so Jarquez did have the one question about the Learn. I am going to put him off for a little while. Let's make sure. Maybe I will answer it during the lesson. If I don't, we'll come back to that question. So if you're just joining, I'm getting connected here to my iPad. If you're just joining, one of the questions was where are we on the test? Right now we are nowhere on the test. So I was explaining possibly before y'all came in that I had you guys were 5th in line. So I gave 5 tests last week. You were the 5th ones. And so your last, the other 4 are graded, but I did take Easter Sunday off. I did not do any schoolwork on Easter Sunday. So I'm hoping to start grading those tonight, and hopefully I can get those done. One of the things that my email did say is that you should allow me a week. So I want to get those back no later than Thursday, but I'd really like to get them back sooner than that. So I've got an appointment that could be pretty long this afternoon. So I know a good bit of time will be taken up this afternoon. So anyway, before I start on chapter 5, I just wanted to show you guys the calendar for the rest of the semester if you haven't been paying attention to this. So we're right here in section 5.1. This is what we're going to be covering today. You can see we are at the end. Okay, I mean, we're here. So I don't give up now. Don't let your guard down now. Now's the time to really sprint towards the finish line and to get your stuff done. For the record, I'm telling myself the same thing. If I'm just outright honest with you, the 60-hour weeks are starting to wear on me. And so I'm telling myself to keep pushing through. And so I am telling you that, but I'm having to follow my own advice about that. So we're all in the same boat as that's concerned. So keep pushing, keep struggling, keep working. I know last week Jonathan asked me about an exam and how I'm going to get you guys to study for the exam. Still working on that. I've got a couple of ideas that for the time being, I'm trying to think through all of the consequences of my decisions. And so just trying to work through that, but I'm hoping to have a little bit more information for you. If not later this week, then by the beginning of next week. You will notice that your last test is 2 weeks from today. And so just be aware of that. And then the final exam is on Friday. Okay. I'm tempted to put that on the last day of class, the 29th. I'm not decided on that, but can you start thinking that direction? If I put it on the last day, the reason I'm thinking about putting it on the last day of class is that my grades are due the next Monday morning. So if I give it to you on Friday, it doesn't allow me a whole lot of time to get my exams graded and the grades figured by Monday morning. And so we have been given permission to give exams on the last day of class. So just be aware that I am considering putting the exam here instead of Friday, May 1st. Okay. I will probably, it's on my to-do list to send out a survey that talks about that. So, so just kind of be on the lookout. It's not going to come out today, I'm pretty sure, but within the next day or two, a survey about that should be coming out to see if that's going to cause any issues. Okay. Any questions on that? No? Okay. All right, so then let's go ahead and just jump into section 5.1. And first thing that I wanted to talk about, so basically we're talking about the derivatives of the natural log in this particular section. And we dealt with, the last time that you've seen natural logs, hang on a second. Somehow I'm getting some feedback.
Yeah.
And I'm not sure what happened. Okay, but I'm not hearing it now. Are you guys hearing it?
Not anymore. It was just for that little bit.
Okay. So the last time that you guys dealt with logarithms was in Math 110. So you did not see logarithms at all in Math 111. So it's been at least a whole entire semester since you've seen logarithms. So you are going to have to kind of remind yourself of logarithms. And so let's take a look at some properties that you had back in Math 110. And so one of the properties is that any logarithm of 1 is always going to equal 0. Any logarithm of 1 is always going to equal 0. This is the backward version of like anything to the 0 power is always 1. Okay, so this is the backwards version. Remember that logarithms and exponents undo each other, like squares and square roots, or multiplying and dividing. So a log and a power undo each other. Specifically, the natural log always undoes e to a power, the base of e that is like a 2.71 something something something. So e is its own special number. So again, these are all just review things that I'm trying to remind you of. Number 2, we're going to use this quite a bit. And so when you take the log of a product, and you'll see here, here's my product. I'm taking the log of a product. The log of a product is going to be the sum of 2 logs. So this will be the same thing as the natural log of A plus the natural log of b. This goes back to that x. Go ahead.
So these, the natural log, or these properties, they apply for log and natural log?
Correct. So a natural log is just a special case scenario of all of the generic logs. So we would say that just a generic log is a very big umbrella term. It could be a log base 3, a log base 9, a log base 10, a log base 21, a log base any number. The natural log is specifically the log base E. So it's a special type of log. Okay, so yes, but these rules do apply, and you'll see this later in the chapter because I repeat these exact same rules later in the chapter with the generic log. But since we've already seen them, it will be easy to adapt.
Okay.
Rule number 2 is the backwards version. Do you remember that rule in like pre-algebra, Math 101, Math 102? We've worked with it since then as well, that said when you multiply like bases, you add the powers. That's essentially what's happening here. The logarithm is a power. So when I'm adding these two logs, literally this is a power plus a power. That is literally what you're working with, is a power plus a power. So so I'm multiplying like bases, so therefore I'm going to add my powers. All right. Rule number 3, very similar to rule number 2, just the division version. And so this is going to be the natural log of A minus the natural log of B. The way that we say that is the log of a quotient is the same thing as the difference of two logs. The log of a quotient, so that's what you see here, is the same thing as the difference of two logs. And then the last rule is when you take the log of something raised to a power, you get to take the power out to the front, and you're going to multiply. So this is going to be the power of n times the natural log of a. The backwards version of this rule, do you remember the rule in pre-algebra that says when you raise a power to a power, you multiply your powers? Okay, well, remember that I just got finished saying that a log is a power. So basically what we're doing here is there's my power times my power. Okay, so literally I'm raising a power to a power, so I'm going to multiply those powers. So that's the rule that goes back to. All right, so I gave you at the top of the page just the definition of the natural log of x. That's given information. You don't have to do anything with that other than I'm going to use it here to find the derivative. So I'm going to take what's at the top of the page then, and I'm going to rewrite it down at the bottom of the page. The only difference is that at the top of the page, it's a definite integral, and at the bottom of the page, it's indefinite. That's the only difference. So I've taken, this is just my definition of what I gave you originally. And notice that what I've done is I'm taking the derivative of both sides. Okay, so, and you're allowed to do the same thing on both sides. That's totally legal. You've done that your whole entire mathematical career. And so I'm taking the derivative of both sides. This is just a little bit of math theory that I'm giving you. So the derivative of the natural log then, this guy, is going to equal 1 over x. And in a minute, I'll tell you why I'm getting rid of the c. And you say, well, how did you get that? Well, if you'll look here, what do derivatives and integrals do to each other?
Cancel out.
Yeah, they undo it. Remember, it's an antiderivative. So a derivative and an antiderivative undo each other. So I undid those two, which is how I was left with the 1 over x. But I don't need the c piece of this, so you can actually drop the c piece because the derivative of the constant is just going to be 0. So we don't have to worry about that piece. And if you will look on your formula sheet, look at the top half of the formula sheet. You are looking at number 9. Number 9. So what you've done, what you have on number 9 is it says the derivative of the natural log of u is equal to, now I'm going to write it a little bit different so that you can see it, okay? It's equal to 1 over u. That's what we just got finished saying in the work that I was showing you, times u prime. Okay, and you say, wait a second. What? Do you remember chain rule? Derivative of the outside times the derivative of the inside. Do or die, right? The derivative of the outside is the 1 over u part. But then this guy might be a little bit ugly. So the derivative, I have to multiply that by the derivative of the inside. Okay, so this u prime then, this is just the derivative of the inside piece of that. All right. So that's why they put u prime over u. It's the same thing. All right, so let's just jump into some examples then. Let's look at number 46. All right, so we're asked to find the derivative. Okay. And so if you have the derivative here, what would the derivative of the outside be? According to my formula sheet or according to the little bit of work that I just showed you? Just the derivative of the outside. Go ahead.
1 over 2x squared plus 1.
Okay, so 1 over 2x squared plus 1. Literally, it's 1 over the copy. Okay. So that's the derivative of the outside, but then let's do the chain rule and take the derivative of the inside. So we're going to multiply by the derivative of the inside. So what's the derivative of the inside then?
4x.
4x. Okay, now, so that's, we would have written that as 4x over 2x squared plus 1, just by multiplying our fractions together. Okay. All right, let's see here. This is timely. My sister-in-law sent that to me this morning. So apparently, I did not do a fact check on this. I don't know if it's true or not. But the meme says that Sir Isaac Newton invented calculus during the plagues. So maybe we're getting close, huh? I don't know. I'm not bored. I'm putting in too much work to be bored. So, all right, let's look at number 48. When you look at number 48, what is the overall operation here?
Multiplication.
Yeah, so we're going to need to use the product rule, right? Oh, man. Isn't this a great time to be talking about things like the chain rule and the product rule? Right before the exam. See, I'm just going ahead and I'm giving you a review for the exam. So this is good timing. All right, so let's do the product rule. So what was it that the product rule said?
There's the derivative of the first.
Okay, so derivative of the first. Okay, so hang on. So what's the derivative of the first?
2x.
2x. And what are we supposed to do with the derivative of the first?
Multiply by second.
Multiply by the second.
Okay, so let's just copy down the second piece, the ln of x.
Plus.
And then we're going to add, right?
Right.
What will we add?
Copy first.
Okay, so x squared times
the derivative of the second.
Yep. And what is the derivative of the second? What are we learning is the derivative of the second?
U prime over u.
U prime over
1 over x, right? Because I'm not using u's on this one. This one has x's. Okay. Now, it is 1 over x, but if I multiplied by the derivative of the inside, what's the derivative of just the x piece?
1.
Yeah, so I don't need that piece. Okay. All right, let's clean this up a little bit. So I've got 2x natural log of x. You can't do anything with that first piece. But what can you do with the second piece?
Make it an
You could
Yeah.
just make it X.
Yep, absolutely. Okay, so a pair of x's can be canceled. Okay. All right, number 50. Before I jump into the derivative on this one, what is your thoughts on this one?
X.
Can we get it out of the, can we set it all to the 1/2 power?
I would,
Everything?
yes, I would. So I'm not even working with derivative right now. All I'm doing is rewriting the original question. So I would say that this is the natural log of x squared minus 4. And I'm not going to write this down, but it's to the 1/2 power, right? Go back to your Math 110 rules. When you have a natural log of something raised to the power, what can you do with that power?
Put it in the
Oh,
front.
right.
Yeah, absolutely. So instead of saying that it's raised to the 1/2 power, let's multiply by that power out front. Oh, because now it's just a constant multiplier, and that makes it way easier. Okay. All right, so now I'm ready to find the derivative. Now again, I don't have to do derivative of the first times the second plus the first times the derivative of the second. It's just a constant multiplier. So the 1/2 piece for the time being is just out in the front. Now, what is the derivative of log x squared minus 4?
1 over
1 over
x
x
squared
squared
minus
minus
4.
4.
Okay, so we've got 1 over our copy. Okay, now you notice I didn't put the 1. All right. That's the 1 over the copy. That's the derivative of the outside. What's the derivative of the inside?
2x.
And that's what I'm just going to throw up on top.
Then multiply the bottom by 2.
Actually, I'm not
well-
going to.
Cancel out 2.
Cancel out the
Yeah,
two.
I can cancel the 2 that's in the numerator with the 2 that's in the denominator. So that y prime then will be x over x squared minus 4.
Okay.
I was getting some lag during that, and you were cutting out. Can you explain how you went from ln of x squared minus 4 to the 2x? That again? Can
Sure. So remember that my derivative, the derivative of the natural log of x is equal to 1 over x. Okay? This guy and this guy are identical. All right? So did that just answer your question?
I think so, yeah. You just used like the, well, actually, no, continue. I thought it did.
Okay, I'll continue. So the 1/2 was just here. That's no big deal. This is that copy that's down on the bottom. Okay? Which that piece of it is the derivative of the outside. So when I take the derivative.
Oh, and then you just put the derivative of the inside on top.
Correct.
Okay.
Does that make sense?
Yes, ma'am.
Okay. All right, any other questions on that one? All right, let's do another one. All right, what are your thoughts on this one?
So we can use one of the 110 rules to split it into 2 ln's.
Okay. Yeah, because overall here, I've got the log of 2 things multiplied together. Okay, so use rule number 2. What was that?
Would you do the chain as well since you have the power?
So actually, I'm not even working on the derivative yet, but so let's wait on that one, Jarquez. Okay, let's just get it rewritten to make life easier first, Then we'll worry about what kind of rule to use. Okay, so so let's go ahead. Again, I'm not finding the derivative. I'm just rewriting the original question. So this is going to be the natural log of t plus, leave yourself a little bit of space, the natural log of t squared plus 3 all raised to the third power. Right? Because Math 110 says that when you take the log of a product, that's gonna be the sum of 2 logs. Now there's one more thing I can do.
Take the power and multiply by it.
Yeah, so that Math 110 rule number 4, the Math 110 rule number 4 says that this power here can go to the front of its own log. Okay, so let's take one more line to rewrite before we get the derivative. Okay. Now, Jarquez, I want to go back to the question you just asked. Because when I did have the power, I was going to have to use the chain rule. But do I have to use that chain rule now with the power piece? No, I don't. So actually, this is making life a lot simpler. Let me even back up a little further, guys. If I had just jumped into finding the derivative with this original, holy cow, I would have had to use the product rule. And inside the product rule, I would have had to use the chain rule. That would have gotten really, really ugly. I know, I did it. I've got it on paper right here. It's nasty. So if I go back and use those Math 110 rules, I can make my life a lot simpler. Now, let's go get the derivative. So this is going to be y prime now. And remember that derivatives, I only have to find the derivative of each term. So what's the derivative of the first term?
1 over t.
1 over t. Yep. Plus, well, 3 is just a constant multiplier. It's not a power anymore. So we've got 3 times, what's the derivative of natural log of t squared plus 3?
1 over t squared plus 3.
Okay, so we've got the t squared plus 3 on bottom because that's my copy. The copy goes on the bottom. And what is it that goes on the top?
2t.
Yeah, the derivative of the inside, so the 2t. Eric, did that make a little bit more sense this round?
It did, yes, ma'am.
Perfect. Now, the only thing that I'm going to do at this time is just to clean up what's there. And quite frankly, the only thing I can clean up is the 3 times the 2 to make it into a 6. Okay, so this is going to be equal to 1 over t plus 6t over t squared plus 3. Okay. All right. How about you guys try this one? I know I can't get you into groups like I normally do, but I'm doing all the work here.
I know that there's subtraction in there somewhere.
Oh, nice.
So would it be the natural log of 2x minus the natural log of x plus 3?
I like it. And this is not a derivative yet, right?
Correct.
Okay, so Plunkett got you guys that far. Okay, you're on your own. Do the next couple steps on your own. All right, do you have the first term?
1 over x.
1x.
Okay, so let's walk me through it. So you had 1 over 2x first, right?
Mm-hmm.
And what did you put up on the top?
2.
2.
How come?
Derivative 2x.
This derivative.
Yeah, the derivative of the inside, right? And so that's how you guys got the 1 over x. So I agree with you on that. Minus, okay, so walk me through your brain work on the next piece. What goes on bottom?
X.
X plus 3.
And what goes on top?
1.
1.
Yeah, 1. So you've got 1 over x minus 1 over x plus 3. Okay. All right. Whew. Now, my brain splits into 2 pieces when I look at this one. Okay, so there's 2 totally legit ways to work this. I'm gonna just ask you guys first. What should I do?
Just a standard quotient rule.
So quotient rule would definitely be something. That's what I heard from Chris. I heard somebody else saying something. I just don't know what it was. Can you repeat that?
Could you move the t from the bottom to the top?
How so?
Make it the natural log of t times t to the negative first power.
Yeah, so Jarquez, if you're going to do that, what I would do is I would put the t to the negative first power in the front so that nobody confuses whether you're taking the natural log of it. So I would do t to the negative first times natural log of t. Do you understand why I would do it that way instead of the way you said it?
Yes, ma'am.
Yeah. So honestly, guys, now in that case, you wouldn't be working the quotient rule. What would you be working?
Product.
The product rule. Okay. So it's really your choice as to which one you want to do there. So Chris said the quotient rule first. Since we haven't practiced the quotient rule today, let's go ahead and, seeing as how this is a good time to be practicing things, let's practice the quotient rule. So my derivative, all right, what's the derivative up on top?
The derivative of the top multiplied by copied bottom.
So you are correct. I'm just asking, what is the derivative of the top?
Oh,
Over t.
1 over t. So there's the derivative of the top. And Chris, you were right, times the copy of the bottom. What's next in my quotient rule? Minus. Next piece?
copy of the top.
So that's natural log of t times?
1.
Yep, 1 derivative of the bottom. All over?
T squared.
T squared.
T squared. Okay. So we'll clean that up. The first term on top, the t's are
Is
going to
1.
cancel. Yeah, it's just a 1 minus the natural log of t.
Which is, oh, yeah, minus the natural log of t.
All over t squared. Okay. Jarquez, if you had wanted to go about it with the product rule, you could totally try that. You should land in the same spot we did.
Yes, ma'am.
Okay. All right. Let's get one that's a little bit funky.
Actually, with the way Jarquez is going to do it, I'm stuck at -1 natural log of t plus 1 over t squared.
All right, so the derivative of the first is going to be negative t to the -2, yes, times the second plus the first times the derivative of the second.
How come you got negative t to the negative 2?
You subtract a power. See, you remember when you're doing, okay, what's the derivative of x to the 4th? You went the wrong way, didn't you?
Yeah.
So Plunkett, actually, thank you for making that mistake. Which I know is a weird thing to say, but it's just a really good reminder that at this point, we've done integrals and we've done derivatives. So sometimes we're adding one to the power, sometimes we're subtracting one from the power. So just be careful about the direction that you take on that. Okay. Do I need to go any further, Plunkett, on that?
I still want to see how they add up.
Okay. So, so this is going to be this first term, -1 over, hang on. Negative natural log of t over t squared, right?
Yep.
And this one is going to be, this term will be 1 over t squared.
Gotcha.
And yeah, they match up.
Like bases, right?
Yep.
So you can, or bottom, yeah.
Common denominator.
That, yes.
Yeah, that. Math is a language, right? You guys are learning the language. You're not just learning how to do the math, you're learning how to speak the math. Okay, 58. This one's weird. Okay, if I'm going to, by the way, there's no way to clean it up before I start. There's nothing I can do, okay? So I can't make it any simpler than it already is. So the only thing I can do is just go ahead and start in on the derivative. Now, what derivative rule am I gonna need to do?
Chain.
Yeah, it's the chain rule. So this is gonna be derivative of the outside first. The outside is the whole thing, okay?
1 over the ln of x.
Yeah, so it's 1 over a copy, and the copy is what I'm taking the natural log of. Okay, so I've got 1 over ln of x. There's the derivative of the outside. Okay. Now, let's multiply that by the derivative of the inside.
1 over x.
1 over x. And then last but not least, we'll say it. We don't need to write it, but let's say it. Multiply by the derivative of the inside of the inside.
Oh, which is on.
1. And I don't need that piece. But if it was an x squared there, yeah, I would need to be taking the derivative of the x squared. Okay. So this one is a 3-level chain rule. Derivative of the outside times the derivative of the inside times the derivative of the eensy-weensy inside. Okay. The only thing that I can do here for cleanup is to just rearrange the denominator. So I'll have 1 over x ln of x. And just to make it a little prettier. So as ugly as it was, it really wasn't as bad as it looked. Thoughts?
1 over 3 to the front.
Okay.
Subtract the two terms, so ln x minus 1 minus ln x plus 1.
Okay, and what do I do with the 1/3 in the front?
Has to go to both, doesn't it?
It does have, you can either do a 1/3 times a whole entire quantity, or you can go ahead and distribute the 1/3 to both pieces. Either way, okay? So I have 1/3 natural log of x minus 1 minus 1/3 natural log of x plus 1. Again, the 1/3 is a GCF, so it can be rewritten out in the front times a whole entire quantity. People tend to forget it when it's written like that. So, all right, so this is just simply rewriting. I haven't found the derivative yet. All right, so I still need to find the derivative. So we'll say y prime, it didn't have a letter on it. We'll call it y. Y prime is equal to, all right, so let's just take it, okay, 1/3.
1 over x
Multiplied
minus
by
1.
1 over x minus 1.
Times 1 over x minus 1. Technically times what?
1.
Yeah, don't need to write that. Minus, okay, what's the next term going to look like?
1/3 times 1 over x plus 1
Technically times
times
a
1.
1. Not necessary. So then there's not a lot of cleanup I can do here, but I would just say 1 over 3 quantity x minus 1 minus 1 over 3 quantity x plus 1. Yes, there is more that you could do. You could get a common denominator and all that kind of good stuff, but it's not necessary.
1 over 3x minus 3 is the same thing, right?
It is. But do you
Okay.
remember that from chapter 3, factored form is best?
Right, yeah. I was just making sure.
Yes, but you're correct. You're correct.
Like, you wouldn't have counted wrong for that.
No.
Okay.
No, I wouldn't. Okay, 62. I would have in chapter 3, though. We weren't doing LNs back then, but I'm just saying, if you had given it to me other than in factored form, I would have counted it wrong in chapter 3.
I got you.
So might as well practice what can be wrong somewhere else. All right, thoughts on this one?
Period the LN throughout. No.
No, and the reason is that this is not multiplying, so distribution doesn't work.
Oh yeah.
So distribution only works when when the operation is multiplying, and that's not multiplying.
We just take a normal derivative, right?
Yeah, you're gonna have to. So is there any cleanup though that I could do first?
Make that 4 plus x squared into or 4 plus x squared to the half power instead of what it is.
Yeah, that's the only thing you can do. You can't even move your power out to the front or anything like that, but you can at least make it into a half power. So that's about the only cleanup you can do. Not about, it is the only cleanup you can do. Okay, so the outside then is a log. Okay, so the derivative of a log, we start out by saying it's just 1 over a copy. Okay, and this one's so ugly that I am gonna write it as 1 over the copy, and then I'll multiply by the derivative of the inside, just because it's ugly. So 1 over the copy is going to be x plus quantity 4 plus x squared to the half. So that's the derivative of the outside, okay? The derivative of the inside then, so what's the derivative of the first piece?
1.
1. Plus, what's
1
the
half.
derivative of the next? Okay, so
1
we've
half
got
times
times,
4 plus 2x.
no,
Power up.
not 4 plus 2x, no.
X squared.
Plus x squared, because we're
Yeah,
copying
4
the inside.
Right. Half times the copy raised to the
Negative 1/2.
negative half. Okay, so there's a derivative. This is another chain rule. So there's the derivative of the outside, and then you want to take this and multiply by the derivative of the inside.
Which is 2x.
Yeah,
2x.
now is where we're using that 2x. Does that make
So-
sense?
Yep.
Okay. So yeah, let's talk cleanup then. I'm gonna change colors here. Just in this term right here, because everything's being multiplied together, notice that I have a 2 on the bottom and a 2 on the top. So those 2's can be canceled. Yeah,
Could
that's all I'm
you-
gonna, go ahead.
Would we want to bring the second half of the second term there, would we want to bring that down to the bottom and put
Probably.
it back under the square root, or do we want to keep it out of the square root?
A square root or not, I don't know that I really have a preference on that, but I probably would get rid of the negative power. Okay, so, all right, so let's go ahead for the time being and just keep the first factor the way it is. So I've got 1 over x plus quantity 4 plus x squared to the half. I didn't do anything with that one. The second one, I've got 1 plus x over 4 plus x squared to the half. The only thing that I could do here would be to multiply. I could, this is just one fraction. I could take that one fraction and distribute to the first and distribute to the second. I don't really know that that's necessary though.
So in the form that
Actually, it's
in,
going to
would-
turn out really nice. So let's do that. What'd you say, Chris?
if we were to submit it as it is now, would that be an acceptable answer?
Yeah, I don't know. You'd have to look on WebAssign. I can't remember if they accept that or not.
Okay.
Okay. Tell you what, I'll make this a bit of an assignment. It doesn't get graded, but here's something I want you to try. I'm not even going to do the rest of the math for you. I just now mapped out what you would do next. And I'm going to go ahead and just tell you, you're going to end up with a 1 over 4 plus x squared to the half, which is a quite pretty answer compared to what all that mess is right now. So my suggestion is try that one on your own, not right this minute, but try it on your own. See if you can come up with that. Okay. Now,
Let's see how.
so let's see here, Jarquez.
Yes, ma'am.
The question that you had from the learns, was that answered?
No, ma'am. We didn't really have any like that.
Okay, so Jarquez, can you go back then and can you tell me, can you repeat to me what the question was?
It was because it was telling me to express the equation in exponential form, and it was the natural log of 3 equals x. And I was wondering when you
Just like that?
And it was
Okay.
e to the x power equals 3. I was wondering, we always use e.
Yeah, so the natural log is automatically connected to base e. Literally, the natural log of something is the same thing as log base e of that thing. It's just that this is an improper way to write it, but it's what it means. Okay, so Jarquez, one thing that you could do is you could make these two sides, the left side and the right side, make them both into powers, where your base is an e raised to the. And as long as you do the same thing on both sides, that's legal. Okay, so this is something that you would have done in Math 110, but it has been a while since you've done this. So then I think, Jarquez, it's really easy to see how we got the e to the x piece. I didn't do anything with that.
Mhm.
An E and a natural log, they undo each other. Okay, E's undo natural logs undo E's, so that means that I'm only left with a 3. Does that make sense?
Yes, ma'am.
Okay. There's one more way I can explain that, Jarquez. And again, I'm using MAT110 concepts here. If you write it wrong to where it says log base E of 3 equals X, that's your original equation. Yes, it's written wrong, but that's what your original equation means. Okay. If you turn that into an exponential, the way that I taught my Math 110 is that you're going to do something like this. So you start out with your base, which is E. You raise it to the power of X, and that is equal to the 3. Okay.
Yes, ma'am.
So, and if you need, I'll try to find the graphic that I use for Math 110, and I'll try to post that onto the notes before tomorrow. Okay.
Mhm.
All right, guys, it is officially 1:55. Do you have any other questions before I let you go?
So we're meeting again tomorrow to continue going over this.
Yeah, I'm fairly certain I don't have time to make any videos and compress them and load them into YouTube before tomorrow. So as
Okay.
long as I don't have time, then yes. Going back to that schedule. So I was supposed to cover 5.1, but I've given myself 2 days for 5.2. If I get behind, I'll make it a point to make the videos. For now, we'll just have a normal class time tomorrow.
Okay, then.
Okay, sounds good.
All right. Thanks, guys. See you tomorrow.
See you.
Bye.
Thank you.